Today we're diving into a fascinating topic that sits at the crossroads of two powerful fields: artificial intelligence, AI, and chemistry. Now, you might be wondering, what does AI, the technology that powers self-driving cars and virtual assistants, have to do with chemistry, the science of matter and reactions? The answer is a lot. Chemistry, the foundation of everything from the air we breathe to the medicines that save lives, has long been a critical part of scientific discovery and innovation. But until recently, exploring new chemical compounds, understanding complex reactions, or designing materials for new technologies was slow and expensive. That's where AI comes in. AI, with its ability to analyze massive amounts of data, predict outcomes, and recognize patterns, is transforming the way chemists work. It's helping researchers design new drugs faster, discover materials for better batteries, predict chemical reactions with greater accuracy, and even create sustainable solutions for the environment. In essence, AI is making chemistry faster, more efficient, and more innovative than ever before. In today's discussion, we'll explore how AI and chemistry are coming together in groundbreaking ways. AI is speeding up drug discovery, enabling the design of smarter materials, predicting chemical reactions, and much more. We'll also look at how AI is helping chemists tackle global challenges, from climate change to pollution. By the end, you'll see how AI isn't just a tool for tech companies. It's becoming an essential partner for chemists, unlocking new possibilities and opening up a world of exciting advancements in science and industry. Before we wrap up, I want to mention that this video is actually a continuation part 2 of a previous video I did about chemistry. If you missed part 1, don't worry. You can easily find it on my YouTube channel. Just head over there to catch up on all the foundational concepts and insights I covered earlier. So if you're interested in diving deeper into chemistry and how it's shaping the world, make sure to check out the first video as well, and stay tuned for more exciting content ahead. Chemistry is absolutely central to understanding how our world works. It's the study of matter, its properties, composition, structure, and the changes it undergoes during reactions. From the air we breathe to the food we eat, chemistry is involved in nearly every aspect of life. Here's a breakdown of its importance and how it shapes our world. 1. Chemistry's role in our world, life and health. All biological processes are chemical reactions. From how we digest food to how our cells produce energy, chemistry explains it all. Medications, vaccines, and the very materials used in medical devices are the result of chemistry. Environment. Understanding chemistry helps us tackle pollution, climate change, and sustainable energy. Chemistry gives us the tools to create cleaner fuels, reduce waste, and develop renewable resources. Technology. From materials used in electronics, like semiconductors, to the development of new, lighter, and stronger materials. Carbon fiber, for instance. Chemistry drives technological advancement. The development of nanotechnology and quantum computing also has deep roots in chemistry. Agriculture and food. Chemistry is involved in fertilizers, pesticides, food preservation, and flavor enhancement. It helps increase crop yields and ensures that food is safe and nutritious. 2. Is chemistry important? Yes. Chemistry is one of the most fundamental sciences because it underpins everything else. Without it, we wouldn't have most of the innovations that make life better or even possible. It helps us understand the world on a molecular and atomic level, giving insight into processes that other sciences cannot. 3. How chemistry shaped the world. The Industrial Revolution. The development of new chemical processes revolutionized industries, from the production of steel to the creation of synthetic dyes. This changed economies and society forever. Medicinal advances. Chemistry gave rise to antibiotics, vaccines, and other life-saving drugs that have extended life expectancy and improved quality of life globally. Energy solutions. The discovery of new fuels, energy sources, and storage methods, like batteries, are all rooted in chemistry. The development of solar panels, for instance, is a result of chemical research in materials science. 4. Why learn chemistry? Problem solving. Chemistry teaches you to think analytically, solve complex problems, and understand cause and effect relationship skills that are valuable in any profession. Everyday applications chemistry helps us understand how to make choices in our daily lives, from choosing cleaning products to understanding nutrition and energy consumption. Career opportunities. Chemistry is foundational in many fields, such as medicine, engineering, environmental science, and biotechnology. It opens doors to diverse career paths. 5. Fundamentals of chemistry. Everyone should know. Atoms and molecules. Everything around us is made up of atoms and molecules. The periodic table organizes the elements, which are the building blocks of all matter. Chemical reactions. This is how substances interact to form new substances. Understanding how and why reactions happen is key to everything from cooking to engineering. States of matter. Solid, liquid, gas matter can change states depending on temperature and pressure. This concept is central to understanding many natural processes. Acids, bases, and pH. These affect everything from the food we eat to the environment. The pH scale measures how acidic or basic a substance is, impacting everything from soil quality to health. Energy and reactions. Chemical reactions either absorb or release energy. This is why fuels work the way they do and why some reactions feel hot or cold. 6. AI and chemistry. Artificial intelligence, AI, is transforming the way we approach chemistry in several ways. Predicting molecular behavior. AI can predict how different molecules will react, helping chemists design new compounds more quickly and efficiently. For instance, in drug discovery, AI can help identify potential new medications by analyzing vast amounts of chemical data. Automating research. AI can automate certain parts of the research process, such as data analysis or running simulations. This speeds up the discovery process, allowing chemists to explore more possibilities in less time. Materials science. AI models are being used to predict and design new materials with specific properties, from new catalysts for industrial processes to lightweight materials for spacecraft. Environmental chemistry. AI can model environmental systems and help predict the spread of pollutants, making it easier to address environmental issues like climate change. In essence, AI accelerates the exploration of chemical systems, enabling chemists to make discoveries that would have taken years manually. 7. Connection between AI and chemistry. AI and chemistry are increasingly intertwined, where AI is a tool that helps chemists push the boundaries of traditional chemistry. Whether through predictive modeling, virtual screening for drug development, or analyzing complex datasets, AI serves as a powerful ally in the pursuit of new chemical knowledge. The synergy between AI and chemistry allows for faster, more accurate predictions and deeper insights into molecular behaviors, potentially opening up entirely new fields of research and application. So chemistry is not just about the reactions we observe, it's the key to understanding the world in a much deeper way. Whether it's exploring new medicines, understanding climate change, or creating better technology, chemistry is at the heart of it all, and with AI's help, its potential continues to grow. The connection between AI, artificial intelligence, and chemistry is one of the most exciting and transformative areas of research today. It's changing the way we approach chemistry, from accelerating drug discovery to designing novel materials and understanding complex chemical reactions. Let's break it down in more detail. 1. AI for predictive modeling and simulation in chemistry. One of the most powerful ways AI is helping in chemistry is through predictive modeling. Traditional chemistry often involves trial and error experiments, which can be time-consuming and expensive. With AI, however, chemists can model and simulate chemical systems before actually conducting experiments. Here's how it works. Molecular structure prediction. AI algorithms, like deep learning, can predict how molecules will behave based on their structure. By training on large datasets of molecular interactions, AI can learn patterns that predict reactivity, stability, or properties like solubility and toxicity. This helps chemists design compounds more efficiently. Quantum chemistry and simulations. Quantum chemistry involves calculating the electronic structure of molecules to understand their chemical properties. AI methods, especially machine learning (ML), are being used to make these calculations faster and more efficient, allowing chemists to simulate complex reactions or molecular interactions that would otherwise require enormous computational power. Reactivity prediction. AI models can predict how different molecules will react with each other. For example, they can predict which molecules are likely to form new compounds under certain conditions, saving time in synthetic chemistry. 2. Drug discovery and development. One of the areas where AI has had a profound impact is in pharmaceutical chemistry. The process of discovering new drugs involves screening millions of molecules to find candidates that will work as effective treatments. AI is speeding up this process in several ways. Drug design. AI models can generate new chemical structures that are likely to bind to specific biological targets, such as proteins or enzymes, helping chemists design drugs faster. By feeding AI systems large datasets of known drugs and their effects, the system learns to predict the efficacy of new drug candidates. Virtual screening, AI, is used to rapidly screen large libraries of molecules for potential activity against a target protein. This in silico screening process helps identify promising drug candidates much faster than traditional methods, significantly reducing the time to bring a new drug to market. Biomarker discovery. I can analyze chemical and biological data to identify biomarkers that indicate diseases or predict treatment outcomes, leading to more personalized medicine. Optimization of drug properties. AI helps optimize a drug's pharmacokinetics, how the drug moves through the body, its toxicity, and its solubility. It can predict how a drug will interact with the body's enzymes, how well it will be absorbed, and its potential side effects. 3. Materials design and discovery. In materials chemistry, AI is helping to discover and design new materials with specific properties, from lightweight yet durable materials for aerospace to energy-efficient catalysts for industrial processes. Here's how. Materials informatics. Similar to drug discovery, AI can be used to screen and analyze huge datasets of known materials to predict the properties of new ones. By learning from existing materials, AI can suggest novel compositions or molecular structures that could have desired properties, such as high conductivity or extreme durability. Optimization of materials. I can predict how materials will perform under different conditions, allowing scientists to design materials that perform better under specific conditions, such as high temperatures or aggressive chemicals. This is crucial in fields like energy storage, batteries, fuel cells, or even in environmental science to capture carbon or clean pollutants. Catalyst discovery. AI is being used to discover new catalysts, which are substances that speed up chemical reactions. In industrial chemistry, catalysts are crucial for energy-efficient and environmentally friendly chemical processes. AI models can predict the molecular structure of catalysts that will be effective for specific reactions, reducing the need for exhaustive trial and error experiments. 4. Reaction prediction and optimization. Chemical reactions are often highly complex, involving multiple steps and intermediates. AI is revolutionizing how chemists predict and optimize these reactions. Reaction pathway prediction. AI models can predict the step-by-step pathways that a chemical reaction will take, including intermediate stages and products. By analyzing large datasets of reaction conditions and outcomes, AI learns the likely routes for reactions, making it easier to design efficient synthetic routes for new compounds. Reaction condition optimization. I can predict the best conditions, temperature, pressure, concentration, etc., for a chemical reaction to occur, ensuring that the reaction is not only efficient, but also yields the desired product with high selectivity. This is particularly important in industries like pharmaceutical manufacturing, where precise control over chemical reactions is necessary. 5. Data analysis and chemoinformatics. Chemistry generates massive amounts of data, from spectroscopic results, NMR, IR, etc., to reaction outcomes. AI excels at analyzing large and complex datasets, and it is being used in chemoinformatics, which involves applying computational techniques to chemical data. Pattern recognition. AI systems can sift through vast amounts of chemical data to detect hidden patterns and relationships that may not be obvious. For example, it can correlate molecular structure with biological activity, or predict the toxicity of a compound based on its structure. Spectral data interpretation. AI algorithms can interpret complex spectral data, such as mass spectrometry or infrared spectroscopy, much faster than human chemists. This is helpful in identifying unknown compounds, analyzing reaction intermediates, or determining the purity of a product. 6. AI in environmental chemistry. Environmental chemistry involves studying the impact of chemicals on the environment, and AI is being used to predict and mitigate those effects. Pollution prediction. AI models are being used to predict how pollutants will spread in the air, water, or soil, which helps in designing effective mitigation strategies. For example, I can model the behavior of oil spills or predict the movement of atmospheric pollutants based on weather conditions. Sustainable chemistry AI is also helping in the development of sustainable chemical processes. For instance, I can be used to design chemical reactions that use less energy or produce fewer waste products, which is essential for creating greener industrial processes. 7. The future of AI and chemistry. Looking ahead, the synergy between AI and chemistry is expected to deepen, with even more groundbreaking advancements. Autonomous laboratories. AI-driven robots could one day carry out chemical experiments autonomously, analyzing results, refining processes, and even publishing findings. This would speed up the entire scientific discovery process. AI-powered nanotechnology. AI could help design nanomaterials with precise properties for applications in medicine, energy storage, or electronics, opening up new frontiers in nanotechnology. Real-time chemical process control. AI could be used for real-time monitoring and optimization of chemical processes, ensuring maximum efficiency, reducing waste, and improving safety. AI and chemistry are rapidly becoming intertwined in a way that is reshaping the future of science. By enhancing the speed, precision, and scope of chemical research, AI is enabling chemists to explore more complex systems, discover new materials, design better drugs, and optimize industrial processes. The combination of AI's pattern recognition, data processing power, and predictive capabilities is providing chemists with tools they've never had before, unlocking doors to a new era of innovation in chemistry. In conclusion, the marriage of artificial intelligence and chemistry is one of the most exciting and transformative frontiers in modern science. By harnessing AI's ability to process vast amounts of data, recognize patterns, and predict outcomes, chemists are now able to explore the molecular world in ways that were once unimaginable. From accelerating drug discovery to designing sustainable materials and predicting complex chemical reactions, AI is revolutionizing how we approach chemistry. This synergy not only speeds up scientific discovery but also opens up new possibilities for solving some of the world's most pressing challenges, such as environmental sustainability, energy efficiency, and public health. The potential for AI to push the boundaries of what we know about chemistry is limitless, and its impact will likely continue to grow, unlocking innovations that could shape the future of industries, technologies, and even the way we live. As we look ahead, the partnership between AI and chemistry will only strengthen, creating a future where science progresses faster, more accurately, and with greater potential for solving real-world problems. So, whether you're in the field of chemistry, technology, or simply interested in how innovation is transforming the world, this intersection of AI and chemistry will undoubtedly be a key driver of change in the years to come.